about the NDCI, mainly normalized difference chlorophyll index. So here you can see it's one kind of the chlorophyll concentration. It's also used for the Sentinel-2 and Landsat-8 imagery for estimating the chlorophyll-A concentration. So basically in this paper, they are also used here that NDCI, mainly chlorophyll index formula. And then further they calculated what is the condition about that NDCI, mainly chlorophyll index in the lake of Chad. It's another paper. In this time here you can see Sentinel. So mainly this is the band about the Sentinel, and further Landsat, how they processing it, you can see. Estimating the chlorophyll A concentration, basically you can see the math algorithm for that. You can see here, they use this type of index. Here you can see, okay. So in this time, you can see chlorophyll A concentration in the lake Chad. They are used at this. It's a one kind of index. Mainly, it's a ratio band 5 minus band 4. 3BDA, it's another index or formula. NDCI, it's another formula which we put in this time. NDCI. You can see the violet. So it's another kind of formula. Also for the Landsat 8, they're also using here this type of formula. Okay. Also, you can see the World View 3. It's another sensor. Mainly, it also provides the satellite imagery. World View 3. So from there, they also calculate this type of index. So basically, you can see this type of index you can easily calculate in Google Earth Engine platform, and then you can easily get this type of result. And in this time, they are use this type of sequence. You can see, and for the processing, you can see what they processing about that. So image mainly subsetting about that, then atmospheric correction. So in this time atmospheric correction not need about that. Then also you can see trained data and validated data. Okay, accuracy assessment they are also do in here. So in this time this is the another algorithm. In this time they are combined the Landsat 8 and Landsat Sentinel 2, and they are use this type of index, and further they are just use the train data and also use the training validation data to find out their accuracy. Okay, so in this time how they calculate the accuracy without, oh, okay, you can see they are also calculate the RMC. Okay, it's very important for the RMC, and when you want to calculate the RMC you must need the ground truth data. Okay, RMC or also you can RAE. Okay, so basically this type of root mean square error or relative area error statistical metric for this evaluation purpose for calculating the accuracy. Okay, so it's another way. And finally they are calculate this type of chart. Mainly you can see they are make this type of chart. So basically in this time it's the linear regression chart. So basically in the linear regression chart we have to need some sample, basically ground sample and also satellite sample. They are easily make the correlation and create this type of y equal to this type of things. They are easily calculated. You can see it's mainly correlation between sentinel chlorophyll concentration and the world view at their respective correlation. So in this time they are also make the correlation between the two satellite imagery, and they also make this type of map. In this study, mainly statistical preference, they are used the algorithm. So basically, this type of algorithms are used: 2BDA, 3BDA, NDCI. So this type of things they are calculated for the Sentinel and Landsat imagery. Sort of time they are calculated here, and also you can see the this type of correlation analysis they are also doing here. And finally, they are calculated the chlorophyll about that. So this is another way. In this time, you also check this paper about that. I also send you the link. So in this time, they are combine the Sentinel-2 and Landsat 8 image collection, and further they calculate the chlorophyll A concentration. Okay. So in this time, what we can do in this time in our code, we are just applying the one index, mainly NDCI. Okay, and then we calculate this type of chlorophyll only for the use the NDCI, and then we calculate the chlorophyll. Okay. So if you want, you can also add this type of index which is available in the here for the Sentinel-2 or Lancet 8, then we will also get the more better result about that. Okay, so let's check this paper. In the meantime, I also send you this code link. You also try to check it. Okay, so if you have any question, you can ask me.
We
Any
didn't
question?
do the export.
Okay,
We
for
were trying to
export,
export
yeah. So exporting, click on
the
the tax
image.
tab and you can click to the run. Okay, then it will be exported. The tip of the chlorophyll image map. Okay, further you can easily make the map using ArcMap software or QGIS software you can use and then create this map. So just click to the run, it will be exported the tip format imagery.
You
Is
said
that
the other time you were going to send me the an RGS software, the crack version. Can you please do that?
yeah, you can easily okay, I will send you the link. You can easily get it from here. Basically, it's the getintopc.com. You can simply go to this link and you can easily get the all of those crack version, mainly ArcGIS crack version. You can easily get from here and you can easily download and install it. That is also okay. No? So you can simply search here, getintopc.com and search here, suppose ArcGIS.
Mhm.
You can see 10.1 or all of lot of version you can easily get from here. So from here, you can simply click on here and further download this file, and also you can get the instruction how you can download this install this software. There you can see, you can simply go to the below and you can see the download. Okay, and how to install this software, just simply click on here, you can get the guideline, then follow this guideline and try to install this software. It also okay, no problem. Okay, then you can easily use it. It's called the
Okay.
getintopc.com. I send you the link, you can also try to download it. Okay, so you also try to download. In the meantime, I'll also send you this code link. You also try to check the code and then check what the result you can get. And this is the paper link. Basically, I think it's a best way. This paper, you also try to read this paper on that algorithm, Landsat, Sentinel-2 and Landsat image collection. Okay, I also try to send you the link. You can easily export this map as a TIFF format, and further you can easily work with ArcGIS software to making the map. Okay, so you also try and further face any problem, then let me know. I'll also guide you. No problem. Okay.
Okay. Thank you.
Okay. Thank you. Thank you. Have a good day. Okay. Bye. Okay. Bye. Okay. So let me write the code again. So basically, this time we are using the Sentinel-2 satellite imagery, and we find out this type of Sentinel imagery. So just I simply add the color combination, mainly band combination. From here, I just add this customer stressing. Suppose 98% stressing. and then apply. So now we can get this satellite imagery. In this time, we are developing this code using Sentinel-2, mainly Sentinel-2 surface reflectance satellite imagery we are using here. Okay, so just I simply copy these things from here. Just I paste. It's our image collection. Okay. So for that, we are applying this watermarks. So mainly in this time, from this satellite image, we are just extract the water body. So for that, I apply here that green and short wave infrared band. Okay. Then we try to add the water image. So basically set the water image. In this time here you can see we get this type of water image. So this is a water image we can find out. Okay. So now from this water image we try to find out what is the condition about that reflectance of NDCI, mainly normalized difference chlorophyll index. We try to compute these things NDCI. So for doing these things in this time, mm, okay, so I put the rename. Suppose I put this name. So basically, this code is right for the BOD, but I want to change it as a chlorophyll. So I put here the suppose CAS. Okay, I put this name suppose CAS, and also put the variable name suppose CS. Okay, it's a variable; it doesn't mean anything. So I put here the CS and add bands mainly CS. Okay, just I simply change the variable name, and I put this. It's a CS or chlorophyll function we create, and also put here it also CS image. Then put here that image CS, and further we are just select the band mainly chlorophyll band CS. Okay, and this layer name we put at the layer name. It's a I put at the suppose chlorophyll A. Okay, put the layer name look like that, and further it's also okay, no problem. CS. Okay, we also add the visualization later about that, and further we are just put at that CS function, the chlorophyll function, and select the band name CS. Okay, so further we put the title. Basically, this title is that chlorophyll. I put that chlorophyll A concentration, and now we put this. It's a chlorophyll A and time. And then we also add here that the trend line about the chart. So now let's check what we can get. So run. We have to change it. It's a image CS because I changed the name. Also put the title, legend title. I put the title. Suppose it's a chlorophyll okay, concentration. And now further we change the parameter. Mainly it's a stressing we have to use in here. So this is the image loaded. So we try to add the color combination. Mainly set the color, stressing these things. And I want to show the spacing suppose. 98%. So now you can get the result 0 point, negative 0.73 to 0.1. This is the range about that. And we just put here the resolution parameter. Suppose you can see. So I simply copy this value from here. Copy and paste. I take only for the 2 digit. Further copy and also paste in here. Okay. Then I just try to add here the variable name VIZ, resolution parameter. Just add in our in here. Okay. So now it will set. So now click the run in this time. So now it also set the color with the stressing value negative 0.17 to 0.18, and it shows this type of color. Yes, it will show about that high and low value about the chlorophyll concentration. So now it's loaded. So here you can, so you can get this type of map, and finally we can also export this type of map. Okay, we can easily export, and this map mainly we can find out this type of region. You can see blue color region. It show about that low chlorophyll. Okay, it's a low density of the chlorophyll. Okay, and red color identify this type of green color is also high, yellow high, and red color is the more high concentration of the chlorophyll on this water body. Okay, and what's the trend about the chlorophyll on this water body? You can easily get it from here. You can see in this time it show this type of chart, but we are also change the chart type. Suppose I put here the chart type, suppose scatter or dot notation about that. So for that we can put here that um, suppose dot chart type we put in here. Chart chart type, or I simply search here the docs tab, find out the function. Docs tab, I simply search here chart set. So this is the function you can use. So just I simply copy this function and paste here, put it the dot notation, and further just copy the argument name. Suppose this argument is that mainly scatter chart. I simply copy the scatter chart and put the chart name in here. I need the scatter chart. So in this time you can see I click the run. In this time it create the scatter chart and also make the trend line. You can see we can get the scatter value for the different time. And click on here, we can easily get the scatter line. So this is a trend line. Okay. So using this trend line, we can easily find out the chlorophyll concentration of this lake. So day by day it increasing. Okay. It show about our mainly it show the trend. What is the trend about the chlorophyll concentration? And what is the time period? In this time, it's very important about the time period. We can easily get this time period from where you can see between this time period for the 1 year. If you want, you can also increasing the more time period. Suppose you start from the year of 2016. Suppose 2016, 2016 from 2023. Okay, just I put at that 2016 23. Okay. So now when I put this time period, then we can get the chart between this time period. Okay, what the trend, we can easily get it. So now click the run and let's check what happened. Okay. So in this time, between this time period, mainly 2016 to 2023, what's the trend we can get from here? So click on here, you can see this chart. We can get the data or not here. Just a minute, not change. We have to change the time in here. You have to change the time, yeah, in here. So for the chart, so 2016 to 2016 to 2000, suppose 23. In this time, we create the chart. We can get this chart look like that. Okay, so in this time, you can see you can get this type of things from here. So now click on here. So now we can get this type of chart. Here you can see it show the decline. Okay, for the long time, mainly 2016 to 2024. This time, we find out that this the ratio is the decreasing. You can see it show the this type of result about that. Suppose I want to check about that only for the 1 year. Suppose I put here the 2020. What's happened for 2020 from 2020 this year? What is the condition? So now click the run. In this time we can get the result for year of 2020. Okay, you can see this time we can get this result for the 1 year. It also increasing. You can see this trend line is the high. Okay, high. So it means that it also increasing day by day for this between this time. So this is the way. And now you can see we can get this type of map. Mainly this map show you the result between the year of 2016 to 2023. This time period show you the average result or average concentration. It show you the average concentration of the chlorophyll between the time period year of 2016 to 2023. We can get this type of map. Mainly 2016, 17, 18, 19, 20, 21, 23. Total 7 years. Total 7 years data we can generate from here. You can see this is the result about that. We can get this type of result. Okay, and this is our lesion. So basically, this is our lesion. Red color identify about the high concentration, and this type of color, blue color identify about the low concentration of the chlorophyll about this water body. So now suppose you need the data set for the different time. Okay, for the different time. So you have to change the time in here. So here you can see this is the time. When I put this time, then I can get a total 6 years or 7 years data. Only 7 years data I can get from here. Suppose you need only for the 1 year. So just simply put here the year of 2016 and also put here the year of 2016. Then you got this result for only for the year of 2016. So click to the run. In this time, this map show you the result for concentration year of 2016. But we can get the problem. We check the problem. It show that. Okay, so it show that okay, normalized difference, no band width fee. Okay, we try to check the 2017. 2017 also put at that 2017. What is the problem? Let me check. We check the image
We
collection.
didn't you didn't check you didn't change it down. You didn't change the year down in the other argument. You only change it for the first part. Maybe
Let
that's
me check.
why it's not showing.
S to SR. And it's available from year of 2017. S to SR. It's available from We try to check 2018 what happened. Suppose 2018, from year of 2018. Okay, so now it will work. Yeah, yes, it's work. So yeah, and in this time you can see this map is generated for this chlorophyll map is generated for year of 2018. Okay, what is the condition for water body chlorophyll year of 2018? We can get this result this time. As well as if you want to check, suppose what the time period for year of 2018, so you can simply change in the second part. You can see 2018, 2018, 18. Also put at the year of 2018. So now we can get the result for the times chart year of 2018. What is the condition about that? Okay, you can get this type of chart here. You can see. Just simply open that. So you can get this type of chart. So it show about that high trend. You can see. Okay, so it show the trend line is the up. So high trend we can get. It means that the concentration is the high day by day in year of 2018, or any year you can easily get, or any time period, or any time period. Suppose I want to need the map for month of January. Okay, month of January. So what can I do? I simply change in here. Suppose 1st January, suppose 1st January year of 2021. So or February or March. So just put here. Suppose I put here the 03 March. So now I can get the January to March. Okay, this time period I can got this map. So now click the run, then check what happened. It show that okay, normalize. So I also increase the time period. Suppose 6 or try to 8. So why it not showing? Or try to check suppose 2019 1st January. It also work. In this time it show about the month of January 2019. What is the condition about that this lake water chlorophyll? Okay, I find out this problem. Suppose when I want to put the 2018, suppose 1st January, then it show there is no image for this study area. There is no image. So for that we are just increasing the value. Suppose we put the 10% cloud cover less than. Also it's not work. So further we put here that suppose 50%. Oh my god, it also not work. Suppose 90% cloud cover. Okay, it show that this time period there is no band. Why? We find out the image. Mainly this image is available from year of 2070 0328. Okay, but in year of 2018 it show that there is no band about that. So we try to add the code in the Lake Victoria and then check what happened.
The Lake Victoria in Africa. Can we
Which
use
one?
the one in Africa? The one in Africa.
What is the spelling?
Lake Victoria in Africa. Maybe you just zoom the map of Africa and get it from there. I don't think you can find it in the search box.
Okay, let me check. Yeah, Africa in
Yeah, right there on a Kenya, right here.
Kenya.
Kenya. Yeah, there you got it.
This is the lake, yeah?
No, no. Go down, down. It is down. It's the biggest lake in Africa so far. There you see it, Lake Victoria. Yeah.
Okay, we try to cover this part. Okay, so now let's check what happened. I try to check for year of 2019. We try to put at that less than 1% cloud cover. Okay, so in this time, it creates another problem. It's not available for the less than 1% cloud cover image. It's not available for this lake. We have to add the cloud marks band function to remove the cloud. Or I just Now let's check. Okay, so it also okay. It's our image. We are just add here. So apply. So we can get this type of satellite imagery for this lake, and this is our water body. So it's our water body, and further we try to apply at the chlorophyll. So here you can see we can get this type of chlorophyll result. So basically, this type of region is the high chlorophyll or high density of the chlorophyll. This type of red color indicate about the high density of the chlorophyll. Okay? Once you can see it's high. Or if you want, you can just try to add here suppose chlorophyll. Just try to add the stressing value. Then we also get the better visualization. Simply apply. So this lake is the very, very high concentration of the chlorophyll. So now you can get type of map for this lake. Okay. So further you can easily export it, and then you can see about your time series chart. It show that okay, there's a lot of pixel, so that's why in this time series chart is not working. So further we also try to apply the another thing. Suppose we're just increasing the scale value. Suppose 1000 because our lake is very big. So that's what we can get. Okay, this result show this type of things. In this time, this result show for this time year of 2018 December, January December. This time, what is the happened about this lake? We can get this type of trend about that, and it's our map we created for this lake. Okay. So now you can export it easily. Export image to drive. Just use this function. Export image to drive, and then further you can just put all of those argument one by one. So just curly bracket start and curly bracket in. Then put all of those argument one by one. Suppose you want to export this image. So further you can simply call this variable name about this image. So this variable name is you can see. So this is the variable. I simply copy and paste. Description mainly put the description is a anything suppose CS or CSL only folder. Put the folder name suppose D. File name is remove that. Dimension not remove that. Region will is your boundary which is RY. Scale is that resolution. I put that it's a 10-meter resolution for Sentinel. max pixel value for the big region we have to use 1E13. No, that's not net. And further, we are just click to the run, then it will be exported. Okay, so in this time, what's the model we follow for developing this type of chlorophyll? In this time, we are put at the following for the normalized difference chlorophyll index. Okay, we have to, okay, let me check about that. What is the, okay, ROI, it's the lowercase ROI. So in this time, we are applying this formula is the NDCI, it's the normalized difference chlorophyll index. So you can see the lot of things about using the NDCI. So basically, it's the NDCI index we have to use, and then further we are develop this type of model. So it's the common formula about the NDCI. Mainly, you can see this is the formula about the NDCI. Mainly, it's the red is 1 minus red band divided by red is 1 band plus red band. So this is the formula about that. We can easily calculate the NDCI using this formula. Okay, so in this time we are just applying this formula. In this time you don't need any kinds of ground truth data, or you don't need any types of ground sample data. So that's why it's an index. We are just applying the index, and when you can see interpret this index, high values indicating the presence of chlorophyll A. Okay, suppose we can get the high positive value, it indicating the presence of chlorophyll A. Indicates are the available through the calculate index function or imported from the these tools. So basically, in this time we are applying this formula NDCI, and you can find out there are a lot of algorithm about the NDCI. You can see a lot of paper already published using this NDCI, mainly normalized difference chlorophyll index to estimating the chlorophyll. Okay, you can get the lot of paper about this NDCI, and it's very easy way to develop the estimating the chlorophyll. Okay, so you also try to search on the Google, you can find out a lot of paper